In summary, the GABA receptor channel is made up of 5 subunits. In general, 2 alpha, 2 beta, and 1 gamma. But there could be a lot of other combinations. Here you have 2 alpha and 3 beta. The pore of the channel is permeable to chloride ions. It's an anionic channel. The pore to open, it needs the binding of 2 molecules of GABA, and the GABA molecules bind an interface between alpha and beta, and alpha and beta, alpha and beta, alpha and beta. There is also one receptor site for benzodiazepine, which is called an allosteric agonist of GABA receptor because it increases the GABA current, and this binding is at the interface between alpha and gamma. So here in this receptor on the left, there is no receptor site for benzodiazepine. In general, when the channel opens, the chloride current hyperpolarizes the membrane, especially in adult brain neurons. Sometimes this hyperpolarization is very small or even non-existent, and we speak of silent inhibition. We will see in the next chapter the effect of such silent inhibition. But sometimes the chloride current also can depolarize the membrane. This is a small depolarization. It depends on where the equilibrium potential of chloride ions is compared to the membrane potential. And in developing immature neurons, there is usually a higher concentration of chloride inside in the cytoplasm, and the equilibrium for chloride ions is very different from adult neurons, and we get more a depolarizing current. So remember that the effect of the chloride current depends on the respective values of the equilibrium potential of chloride ions and of the membrane potential at which the current is recorded. The GABAergic synapse. You have here the presynaptic element, an axon terminal, the synaptic cleft, the postsynaptic element, which can be a dendritic spine or a patch of dendritic membrane, or a somatic membrane also, and here a glial membrane. When an action potential arrives at the terminal, it opens the calcium channels, calcium ions enter, and there is a local and transient increase of calcium concentration. Because of calcium-sensitive proteins, it induces the fusion of the vesicles with the presynaptic membrane and the release of GABA in the synaptic cleft. GABA, once in the synaptic cleft, is going to bind to all its receptor sites. So there are receptors on the GABA receptor, and it opens the GABA receptor, and chloride ions usually go in. It binds to transporters here in the glial membrane and transporters in the presynaptic element that help to reuptake GABA and to clear it from the synaptic cleft. So when GABA unbinds from GABA receptors, it has a low probability to bind again because it has disappeared from the synaptic cleft. GABA binds to the GABA receptors, the channels open. GABA binds to transporters. GABA is transported inside glial cells or back inside in the presynaptic element. And then GABA spontaneously unbinds from its receptor sites and GABA channels close.